Alrighty, so this is the first ARM and generally just the first assembly video on my channel. This is just going to be a tutorial on the basics of ARM and ARM64 assembly. To follow along with this video, you really just need a computer that has an ARM CPU in it. This could literally just be a Raspberry Pi, one of the new MacBooks with an M2 or M1 chip, or etc. I have an M2 MacBook here. That's what I'm using. I usually use my ThinkPad, but that has an Intel CPU, so it won't be able to execute the ARM assembly code directly. You could use a VM or something, virtual machine. But yeah, the purpose of this video is to make, the introduction to assembly as easy as possible. A lot of people, including myself, struggled at some point with the concepts and theory behind assembly and the language and the syntax. It's a bit overwhelming, especially if you come from Python. But I really think it's not that difficult if you break it down, and I'm going to try and do my best to do that here and make it as straightforward as possible. So basically, I just created a new folder just called YouTube, because it's sort of going to be a series on my channel, hopefully. And I've got a C++ file which we're going to be using, and an assembly file. So we're not going to be doing pure assembly. It's a mix of C++, so we're going to be calling the assembly files, assembly functions from C++. We're going to be compiling and linking them with this script file. Alright, so simple C++ setup. So we're just going to include the main library. This isn't going to be a C++ tutorial, so I'm not going to explain much of this. Alright, so this is just the basic setup of our C++ file. Yep, okay, so we can actually just dive into the assembly. So I've just named the assembly file a.asm. This is what we're going to be working with. Now in assembly, and especially ARM assembly, you need to define your functions and the function name. So you're going to need to do .global. This is sort of just saying, hey, this function is global and it should be able to be accessed by functions outside, programs outside of the assembly file. So as for instance our C++ file, this should be able to access our assembly file. I'm just going to call it hello. Okay, pretty simple. And now we're going to do some command called align3. All this is really doing is setting up our functions so we can pass things from C++ into our assembly file. So we're aligning the bytes. You don't really need to know what this means. I don't really fully understand what it means, but you're sort of just aligning the bytes so it can interface with our C++ file and take in inputs and variables and stuff like that. So all our function is going to do is it's just going to return a number. Let's just say 1. You can really make this whatever you want. Now I'm going to type out a command, and I'm going to tell you guys what it does afterwards. And then simply going to return. Okay. So what our function here is doing, it's moving the value of 1. It's defined as a hashtag and then your number. You cannot put decimal numbers, like 1.0. You can only put just normal integers with no decimals or fractions or percentages or whatever, just a normal int like this, into W0. Okay, so we're moving the value of 1 into W0. You can think of this as W0 in like assembly. You can think of it in like C++, you can think of it as in W0 is equal to 1 or something like this, right? So think of it like that. And return is sort of just like return 0 from C. So yeah, so in all assembly sort of instructions, we have the mnemonic. So this is the instruction. What we're doing, this could be like add or subtract or divide, but you can't call registers whatever you want. This is just pieces of memory in your computer. You can't just call this like, I don't know, hello or 1. You have to call it a valid register. So this can be W2, W1, 3, 4, 5, 6. You know what I mean? But you can't just really name it whatever you want. And if you're working with floating point numbers, you have to do a function called fmove. This stands for float move, and then you can put like 1.0 into here. And then you have to change this to D0 or S0, I believe. You could definitely use D0. I think you can also use S0 as well. And these are special registers for floats and doubles. Okay, so we're not dealing with that though. We are dealing with normal ints, and then we're just returning from this function. Now what this does is it always returns the value in the 0 register. So if I was to say like W1, I don't think from memory this won't do anything. It only returns what's in W0. Or you could do something like store and then a byte and then return without W0, but that's a bit advanced for us right now. So for now we're just going to do this. We're going to save it. We're going to go over to our C++ function. So now we're just going to do extern, and then we're going to say C, and then we are going to say the name of our function, which is hello. And it doesn't take any inputs, so you can just put in like num1, but that's for later on if we want to like pass numbers into it. And we should be able to just do this. Oh yeah, I've got to define the return type, so it's an int function. Okay. Now you might run this code and go ahead and work, because you might need to put a underscore here, but for some reason I have an old compiler and it doesn't need this, so just play around with whether you need the underscore here or not. Yeah, and it should be alright. So now we're going to call the function. So we're going to go hello, and it should just return int num1 is equal to hello, and then we can print out the value that is returned from our hello function. So we can just do like this, num is equal to, and then we can just do num1 and line, and this should be fine. Oh, std and line. Yeah, okay. And this should work. Now we're gonna work on our bash script, just to, automate the process of compiling the files and linking. I'm going to use the AS assembler. This stands for assembler. From memory it comes with GCC, but I'm not 100% sure. The file to compile is a.asm, and we're going to output an object file, which is we're just going to call a.o. And then for our C++ function, we're going to do g++ ./main.c++, and we're going to link it with our object file, a.o, assembly object file, so we can access the function. It's just like linking it, and then we're going to output, let's just call it main, and then down here we're going to compile main. Just to make it nice and beautiful, we're going to clear the screen beforehand. We're going to save this and see if I've done everything correctly. So now I'm going to make the bash script an executable just by running this. You don't really need to know what it means, but now I can just do this basically. But if you didn't do the step above, you would have to go bash run.sh like that. But now we can just do run.sh, and we'll see if it works. Hey, and it worked. Num1 now, just to show you guys that it's working. We can put like 2 in here. Oh, that is my schoolwork. Go back here. Yep, we've changed that. So we need to go back here. Run.sh, and it says 2. How beautiful is that? Just to show you guys what I was saying before, if I put W1 in here, let's see if it works. I don't think it will, because it didn't used to work. Yeah, it doesn't. Yep, it stored the last thing in W0. Yeah, so it doesn't. So make sure you put it in W0, because that will return. It will return from the function whatever's in the 0th register, the first register. Alrighty. So that is just a simple program there. we could try and pass in something like we can do in num1. So this is now just going to take in a number, and we can just say, just make this number, just to make it easier. Num1 is equal to 55. Yippee. Actually, we'll do 330 because that's the amount of steps I'm on right now. And then we don't even need to do, we can just do num1. I can't remember if I need to do an and here. We'll see if this works. Okay, so now I'm passing in this. Now, since we've passed a number to our function here, we're going to need to retrieve that number from our assembly program. So how we can do that is by using our mnemonic called load, which is just LDR, and we're going to load into W0 our number, which is in the place X0. Now this just means the first argument of the function, okay? So if there was, say, if there was a second number, like something here, right, you'd put x1, okay? And if x0 was an array and you wanted to access the second item in that array, you'd just do this, okay? This just means shift by 8 bits, which is basically what we're doing. Alright, now this should work the same. This should print out our number 333, if I am not mistaken. I may need to put an and here. Let's see. I don't think I do though. Yep, segmentation. Okay, I definitely do need to. So we're going to pass the memory location of our variable instead. A bit rusty, as you guys can tell, with assembly, but this will definitely work now. So 333, there we go. So we've successfully passed in our number here. We've supplied it with the memory location of number 1. This asterisk needs to be here to say, hey, we're putting in a pointer to number 1, and then we're pretty much just printing it out. Look out for some more tutorials on assembly. I'll get into some more complex things, like, you know, printing strings, characters, doing more complex things like if statements, maybe more complex maths. And yeah, if you want to check out one of my projects that I'm working on in assembly, you can just look up Qplexity on GitHub. It's a small quantum computing based simulation library and toolkit. It's written in purely x86 and ARM assembly, so feel free to take a look at that, and I'll see you guys in the next video. Thanks for stopping by.